You know, it feels like just yesterday we were marveling at basic photo filters, and now we're seeing these incredible multimodal models like GPT-4o and Gemini 2 Flash. They can seemingly edit images with just a spoken command. It's wild. And if you're like us, you want to cut through the noise, right, and understand what's really happening.
Absolutely, it's moving so fast. And what's particularly impressive about these leading closed source
Right.
models is their ability to get really nuanced instructions and, well, produce super high quality edits across a huge variety of images. It really shows how far AI has come in understanding both language and vision.
Right. They've definitely set a new bar, a new benchmark. But here's where it gets really interesting for us today. Despite these big leaps, there's still this noticeable gap, a gap between what these proprietary closed models can do and what's actually out there, available in the open source world for image editing. And that's exactly what we're diving into. Our focus today is Step1X-Edit.
Yeah, Step1X-Edit. It's an open source image editing model, and it's aiming to bridge that exact gap you mentioned. The goal is pretty ambitious. Get performance that rivals those top closed source models like the GPT-4o and Gemini 2 Flash. But the crucial thing here is that it offers a transparent way, a reproducible way to get these kinds of results.
Which is huge, right? For anyone who values, understanding how things work under the hood and being able to build on stuff. So how does Step1X-Edit actually, well, work its magic? Give us the basics, maybe without the super deep tech jargon.
Okay, basically Step1X-Edit uses what's called a multimodal large language model, an MLLM. Think of it like an AI that gets both images and text, right?
Okay.
It analyzes your input image and the editing instruction you give it. Then it extracts a kind of compressed digital summary. They call it a latent embedding.
Like a core idea of the image and the edit.
Exactly. Very informative but compact representation. And this embedding is then used by a diffusion image decoder. That's a sophisticated AI that generates realistic images step by step. It uses that embedding to create the final edited picture.
Got it. So the MLLM understands the request and the image, boils it down to this latent embedding, and then the diffusion model uses that understanding to make the edited image. Now, what are the key things, the key ingredients that let Step1X Edit perform so well, get it close to those big guys? What makes it stand out?
Well, there are two main things, really. First, the team built a completely new training data set, very high quality, specifically for this kind of editing.
Okay, data is key.
Absolutely. And second, they developed a new benchmark for testing these models called GEdit-Bench. And what's really smart about GEdit-Bench is that it's based on real-world user instructions, how people actually ask to edit their photos.
Uh-huh. So it's not just about having tons of data. It's about the right kind of data and a way to measure success that actually reflects how people use it. That seems critical. So our mission for this deep dive, then, is to figure out exactly how Step1X-Edit narrows this performance gap with the closed source models, and what this all means for the future of open source image editing. We want to give you a really clear picture of this exciting development. Let's maybe start by looking at why editing images just using natural language, why that's actually pretty tricky.
Yeah, that's a great place to start, because on the surface, saying add a cat or make the sky blue sounds simple, right? But what are the real hurdles for an AI?
Exactly. What makes it so tough for an AI to get it right every time?
Well, there are a few layers. First, language itself is just nuanced. An AI needs to precisely understand what you mean, including all the little implied things. Second, it has to figure out exactly where in the image to make the change. Location matters. And third, it needs to do all this while keeping the image looking good, looking consistent. You don't want the edits to stick out like a sore thumb.
Right. It's not just making a change. It's making a change that looks believable, that fits seamlessly. You mentioned before that older open source approaches, the ones using text encoders like CLIP with diffusion models, they weren't quite there yet. What held them back?
Yeah, those earlier methods, often relying on things like CLIP or T5 text encoders, they often stumbled with more subtle instructions or really complex ones. They sometimes had trouble really aligning the detailed text request with the specific visual bits in the image. It's kind of like trying to navigate with a map that only shows major highways, maybe. You miss the small streets.
That's a good way to put it. And it highlights why those recent proprietary models, GPT-4o, Gemini 2 Flash, why they felt so groundbreaking. They really upped the game.
Precisely. They showed this amazing ability to do high-fidelity edits, really high quality, across loads of different scenarios, handling complex instructions surprisingly well.
But like we said earlier, all that power came with a catch, didn't it? The lack of transparency.
That's the main drawback. Because they're closed source, how they work internally is basically a black box. This makes it hard, sometimes impossible, to reproduce their results, to really get how they do specific edits, or to build on their work openly, which is, the whole point of open source.
And while there were other open source projects trying to catch up, you mentioned Omnigen and ACA++ before. Where did they fall short compared to these big proprietary ones?
Yeah, those are definitely valuable efforts, don't get me wrong, but they haven't quite hit that same level of overall performance yet. They often still struggle a bit with generalization, meaning they don't work quite as well across all types of edits, and sometimes the accuracy or the final image quality isn't quite on par.
Okay.
So yeah, with those limitations clear, a new approach really felt necessary, which brings us back to Step1X-Edit and their focus on data.
Absolutely. You said data creation is key. Why is getting the data right so fundamental for this kind of task?
Well, the team basically realized that the existing image editing datasets just weren't good enough, either not big enough or not high quality enough. To properly train a model that can handle the huge range of real editing requests people make, you need a massive dataset that's also been, super carefully put together.
And it sounds like they didn't just hoover up random images and text. They had a system.
Exactly, a very systematic method. They started by crawling the web, gathering tons of different editing examples they found. Then they did this deep dive analysis and grouped all the different kinds of edits into 11 main categories. Things like motion change, material modification, adding subjects, style transfer, removing subjects.
Taxonomy.
Yeah. Subject replacement, portrait beautification, tone transformation, color alteration, background change, and even text modification. This structure made sure they were covering pretty much everything you'd want to do.
That's really smart. Break it down. So once they had these categories, what did the actual data pipeline look like? Getting from raw web stuff to usable training data sounds intense.
Oh, it was. It was a multi-stage thing. They first generated something like over 20 million instruction image pairs. Huge number.
20 million?
But here's the key bit. The rigorous filtering. They used advanced MLLMs, including their own internal model called Step1O plus human annotators, to comb through everything. In the end, they kept just over 1 million high-quality pairs.
Wow, only 1 million out of 20 million.
Yeah, roughly a 20-to-1 retention rate. It just shows how serious they were about quality. Their final Step1X-Edit HQ subset is still pretty big compared to other datasets, but the focus was quality first.
That's a massive cut. Quality over pure quantity. Can you give us a couple of examples? How do they actually generate the data for, say, adding or removing something?
Sure. For subject addition and removal, they'd start by annotating objects using a model called Florence 2. It's good at spotting things. Then they use SAM2 for segmentation, basically getting precise outlines. To remove stuff, they used an in-painting tool called Object Removal Alpha. The instructions like remove the person on the left were generated using their Step1O model and GPT-4o. And crucially, humans checked it all at the end.
Okay, a whole chain of specialized tools plus human review. What about changing something like subject replacement or swapping the background?
Similar start, Florence 2, SAM 2. But to ID the objects or keywords for replacement, they used Qwen 2.5 VL and another model called Recognize Anything. For the in-painting, to make the new object or background fit naturally, they used something called Flux Fill. And again, Step1O and generated the instructions, humans verified.
Interesting how they mix and match different AIs for different jobs. What about trickier things like changing color or materials?
Right. After detecting the object, they use zeodepth to estimate depth, how far things are in the scene. This helps understand the 3D shape. Then say you want to change a red car to blue, they'd use ControlNet with the diffusion model. ControlNet is key here because it helps guide the generation to keep the car looking like a car, just changing its color or texture.
Ah, using depth info, that's clever. And text modification, that seems super specific.
Yeah, for text, first they had to figure out what was a valid edit versus maybe just recognizing existing text. They used PPOCR, which is good at reading text and images, plus Step 1. Based on that, they generated instructions like change open to closed. And because text needs to be perfect, humans did a lot of post-processing and refinement.
Makes sense for text. How about things involving movement, motion change?
For that, they actually used video data from a set called Koala 36M. They'd take pairs of frames, then use tools like BiRefNet and RAFT to separate moving objects in the background and estimate the optical flow. GPT-4 then helped describe that motion change as the editing instruction, like make the car appear to be moving faster.
Wow, pulling from video too. What about the really subjective stuff? Portrait editing or beautification?
Two main ways there. They use public before and after beautification pairs, checking them for consistency with step 1, but they also had actual human editors beautify a bunch of images. And then, again, manual checks to ensure quality.
Okay. And style transfer. That's always popular.
They had a neat two-way approach. For styles like Ghibli or anime, sometimes starting stylized and going realistic works better. So they'd extract edges from the stylized image, use ControlNet, and generate a realistic version. For other styles like oil painting or pixel art, they'd start realistic, extract edges, and use ControlNet to generate the stylized version, kind of reverse engineering it based on the style.
Clever, tailoring the approach. Lastly, tone transformation lighting, color grading.
That was mostly done with algorithmic tools, like applying standard filters, simulating things like color grading, dehazing, adding rain effects, or even changing seasons.
Man, that is incredibly thorough, covering so many bases with specific techniques for each. And you mentioned they also put a lot of effort into the instructions themselves, the captions.
Oh, absolutely. High-quality instructions are just as important as the images. They had several strategies. One was redundancy-enhanced annotation. They knew even good AI models might generate vague or slightly off descriptions sometimes, so they used multiple rounds. The output of one round fed into the next as context, making the final descriptions more consistent and accurate.
Like refining it iteratively. Smart. What else?
They also use stylized annotation via contextual examples. Basically, when generating captions, they showed the annotator's AI or human, lots of examples of the style of caption they wanted. This helped keep the tone, structure, and level of detail consistent across the whole dataset.
Using examples to guide the style makes sense. And with that scale, efficiency must have been key.
Definitely. Which led to their cost-efficient pipeline. They started with GPT-4o for the initial annotations, but then they used those annotations to fine-tune their own internal Step1O model. That let them scale up the annotation for the massive dataset much more cheaply.
Smart. Use the big model to train your own efficient one. And the last bit was interesting, bilingual annotation.
Yep, all annotations were done in both Chinese and English. This is great because it makes the dataset useful for more researchers globally. And it helps in training models that can actually understand instructions in multiple languages right off the bat.
Okay, so they built this monster data set, huge, high quality, bilingual. Now let's get into the Step1X-Edit model itself, the architecture. You said 3 key parts.
That's right. If you look at their paper, Figure 4 shows it. You've got the Multimedia Large Language Model that use QuenVL. Then there's a lightweight connector module. And finally, a diffusion and transformer model, a DIT, like FLUX.
Okay, let's unpack that. The MLLM QuenVL. What's its job with the image and instruction coming in?
So the MLLM takes the input image, the user's instruction, and also a specific system prompt, all together in one go. This lets QuenVL really grasp the semantic connection, the meaning between what the user wants and what's in the image.
And you said they discard some information. That sounds odd.
It does seem a bit counterintuitive, yeah, but it's actually pretty clever. They specifically drop the token embeddings related to that initial system prompt. The idea is to filter out noise and really zoom in on the semantic parts that are directly about the edit itself. It helps focus the rest of the model on the specific change needed.
Ah, okay. Like zeroing in on the core instruction. These focused embeddings then go to the connector module. What does that do?
Right, the connector module, they call it a lightweight token refiner. It takes those embeddings from the MLLM and basically restructures them. It creates a more compact textual feature representation. This refined feature then replaces what a standard text encoder, like T5, would usually output in a diffusion setup. Think of it as a super condensed, information-packed summary of the image in the edit request, optimized for the next stage.
So it's the translator, turning the MLLM's understanding into something the diffusion model can directly use. And that last part, the diffusion and transformer, the DIT.
The DIT model, like FLUX, does the heavy lifting of actually generating the edited image. It takes that refined feature from the connector, which tells it what to change and how, and uses that to guide the step-by-step diffusion process to create the final output.
You also mentioned a global visual guidance vector. What's that for?
Yeah, another neat trick using the MLM's output. They average all the output embeddings from Quen and pass that average through a simple linear layer. This creates a sort of overall vibe vector, a global visual guidance signal. It helps the diffusion network get a better sense of the overall scene semantics, leading to more accurate edits that fit the context better.
Wow, it sounds like a really tightly integrated system. The MLLM provides the deep understanding, and that directly steers the diffusion model's generation. How did they train it all?
They used a joint learning approach. So they optimized the connector module and the DIT together at the same time. They started both parts with pre-trained weights from their own Qwen and DIT text-to-image models, which gives a head start. And they picked a specific learning rate to make sure the training was stable, but still reasonably fast.
Okay, so a carefully designed architecture trained together. Now the big question, how do they know if it actually works better? That brings us to their benchmark, GEdit-Bench.
Exactly. This was a key part. They saw that a lot of existing open source benchmarks used kind of artificial inputs, maybe not reflecting how real people edit images day to day. So they built GEdit-Bench using genuine user editing requests they found online, like from Reddit threads. It's about testing against actual user needs, not just lab scenarios.
So these aren't just prompts someone thought up for research, they're real requests.
That's the core idea. They gathered over 1,000 of these real user requests. Then they manually sorted them into those 11 editing categories we talked about earlier. They filtered them for diversity too, ending up with 606 solid test examples, all with real-world reference images. It makes the benchmark much more practically relevant.
That feels like a really important distinction, evaluating based on what people actually do. What about privacy, using real user data?
Very important question. They were careful about that. They had a de-identification process. For each original user image, they first tried hard to find a similar public image that fit the edit instruction. If they couldn't find a good public substitute, they'd carefully tweak the editing instruction itself to keep the intent but make sure the image was anonymized. So yeah, definite focus on ethics there.
Good to hear. So how do they actually score the models on GEdit-Bench? What are the metrics?
They use something called VIE score, Visual Instruction Editing Score. It has 3 parts: semantic consistency, or SQ, does the edit match the instruction; perceptual quality, PQ, does the image look natural, no weird artifacts; and an overall score, O, all scored 0 to 10. And interestingly, they use powerful MLLMs like GPT 4.1 and their own Qwen 2.5 VL 72B to automatically assign these scores. AI judging AI, basically.
Okay, so AI judges based on quality and instruction following. What were the results? How did Step1X-Edit do against the others on this real-world benchmark?
The results were pretty striking, actually. Across those 11 categories, Step1X-Edit significantly beat the existing open-source models, things like InstructPix, 2Pix, MagicBrush, AnyEdit, Omigen, like a really big jump in performance for both English and Chinese instructions.
Wow, okay, that's a serious step up for open source. How did it stack up against the big closed-source ones, Gemini 2 Flash, GPT-4o?
That's where it gets really compelling. Step1X-Edit's performance was right there, directly comparable to those top-tier models. In some areas, like style changes and color alterations, it even edged them out slightly according to the VIE scores. You can see the numbers in their tables.
Comparable to the state-of-the-art closed models. That's huge. Now, you mentioned GPT-4o sometimes refused instructions. Safety filters, how'd they handle that?
Exactly. GPT-4o sometimes wouldn't process an edit due to its safety policies. So, for fairness, they reported results on 2 sets: the full set, all 606 examples, and an intersection subset, only the examples where every model actually produced an output. This gives a clearer head-to-head comparison where possible.
Okay, that makes sense for a fair comparison. And you stressed it worked well in both English and Chinese.
Yes, that bilingual training data really paid off. Consistent high performance in both languages. And it's worth repeating, they got these results with their single unified model. No need for extra steps like providing masks to tell it where to edit. That simplifies things a lot. They have some visual examples in the paper, figures 7 and 8, showing the output side by side. Really helps see the difference.
Yeah, seeing the pictures makes it concrete. Okay, the automatic scores look great. But scores are one thing. What about people? Did they do a user study? Ask humans what they thought.
They did. Smart move. They got 55 people to look at the results on GEdit-Bench. Participants saw the original image and the edited versions from Gemini 2 Flash, Dubao, GPT-4o, and Step1X-Edit, all mixed up. They had to rank them on a 1 to 5 quality scale. Then they crunched those numbers.
And what was the verdict from the human judges? How did Step1X-Edit look?
The results showed Step1X-Edit achieved comparable subjective quality. People generally rated it right up there with the other state-of-the-art models, which is a really strong validation, right? It's not just metrics. People like the results, too. Interestingly, Gemini 2 Flash did score particularly well in the user study. The researchers think it might be because it's very good at keeping the identity of people or objects the same during edits, and users seem to value that preservation aspect highly.
Okay, so maybe not the absolute top pick in every single human vote, but definitely playing in the same league, comparable quality overall. That sounds like a massive success.
It really is. So just to quickly recap their main contributions here. First, they're open sourcing the Step1X-Edit model itself, huge for the community. Second, that whole sophisticated data pipeline they built. Creating that massive, high-quality, diverse data set is a major resource for everyone now. And third, GEdit-Bench, a new benchmark based on real user needs, giving us a much better way to measure practical progress.
Okay, let's wrap up this deep dive then. It's really clear that Step1X-Edit is a significant step forward, a big one for open source image editing. It genuinely seems to be closing that performance gap we talked about, the one between open source and those really powerful but closed technologies.
That's the key takeaway, I think. The implications for just making this tech more accessible, for allowing reproducible research, and for pushing the whole field forward, they're substantial. Having a high-performing open alternative like this empowers so many people, researchers, developers, artists, everyone.
And that new data set and benchmark, they're not just useful for this project. They're tools the whole community can use now to build the next great thing.
Exactly. They provide the fuel and kind of a better map for future innovation in this space. Should really speed things up.
So as we finish up today, here's something for you listening to maybe chew on. With open source models like Step1X-Edit catching up and bringing these powerful editing tools to potentially everyone, what does that mean? What's the potential impact on creativity, on how content gets made, maybe even on democratizing these advanced capabilities? Definitely something to think about. You can dig deeper into Step1X-Edit, find the details, and even check out the open source model itself. We'll link the GitHub repo in our notes. Thanks for joining us for this deep dive.